Hello, ladies and gentlemen, and welcome back. We're looking in this video at question number 5 on our 2018 MMC or Manitoba Math Competition. We've got two parts here, A and B. A, for how many positive integers n is n over 3 a 3-digit integer and 6n a 4-digit integer? Okay. So I feel like the choice of 3-digit and 4-digit were arbitrary, just like I suspect n over 3 and 6n are sort of arbitrary. But they give us some inequalities that I think we can work with, and then we can use those to figure out n. Okay. So if n over 3 is 3-digit, then it quite specifically has to be in this range between 100 and 999. So, and we want n to be an integer, right? How many positive integers? So we can't let n be some fraction or anything like that. Okay, so then that tells me that n is somewhere between 300 and 1,000 times 3 minus 3, so that's 2997. Okay, so we've got a nice little range of values that n can be here. Okay, and then we've got 6n is a 4-digit number. Well, what does that tell us? That tells me that 6n is at least 1,000 and at most 9,999. Okay, so this also can turn into an inequality for n. I suppose we can clean it up a little bit. Divide by 2, and we get 500 over 3 here. Now, the thing to note here is that we don't have integers here, so you gotta sort of simplify that. I'm getting out my calculator. N is an integer. So we need to have 500 divided by 3 is 166.6, so n has to at least be 167. And at most 166. So there's certainly some overlap here. And the other sort of key thing to figure out or to realize is that n over 3 has to be an integer. So n is a multiple of 3. So combining our two inequalities, we can see, well, 300 is bigger than 167, so 300 must be less than or equal to n. And 1666 is the smaller of the two upper bounds. So we've got a multiple of 3 in this range. So we just need to count, well, how many multiples of 3 are in this particular range. Okay, and I think the easiest thing to do when counting multiples of 3 is divide all sides of the inequality by 3. So we're actually putting an upper bound on n over 3 here. 1666 divided by 3. So n over 3 is at most 555. And how many numbers are in this particular range? Well, 555 minus 100, and then you always add on 1 because you haven't counted one of the end points. So that'll be 455 plus 1, 456. So that's how many integers, anything from 300 up to, I guess, 1665. Just double check, divide that by 3, you get 55. And multiply it by 6, and you get 9,990. All right. So that works out quite nicely. I would just poke around, double check. I can't have n be 1667 because if I multiply that by 6, I get too much. Or 1666, well, that would be, they wouldn't be satisfying the multiples of 3. That's the problem there. So, okay, 456, that's our answer for A. And we head right back for B. What do we got for B? Suppose A, B, C are non-zero numbers, and that AX plus A is equal to BY plus B is equal to CZ plus C. So I'm noticing a lot of sort of symmetry. Basically, it's the same statement. And that's also equal to A plus B plus C. Use this information to find the numerical value in the expression x times y times z minus x plus y plus z. Okay. Now, the fact that they've said numerical expression has me thinking, I don't have any numbers in anything that they've told me. There are no numbers in what they've told me. It's all A's and X's and B's and things like that, and yet they want a numerical value. So I say, all right, it's a subtraction. What could I possibly do? And immediately I start thinking that it's 0, and that somehow, for some reason, x, y, z is equal to x plus y plus z. And that's in my immediate thought just because it's numerical value. Now, it could also be something like 1 seems natural, but for the answer to be 16 would seem weird. Okay, it doesn't seem like there's enough information, enough numbers going on here for 16 or negative a half to be an answer. But I could see 0, maybe 1, but I'm definitely leaning towards 0 for a numerical value for this expression. Okay, so let's see what we can see. We don't have a whole lot to go with because we've only got sort of this set of equations and we've got 6 unknowns. But let's copy them down and see what we can see here. So I think the A plus B plus C is key. So if I look at AX plus A is equal to A plus B plus C, and I look at BY plus B is equal to A plus B plus C, and I look at CZ plus C is equal to A plus B plus C, there's stuff to cancel on both sides. Cancel out an A and an A B and a B, a C and a C. So these give me sort of new equations. AX is equal to B plus C. I'm actually just going to rearrange that and solve for X. So X is B plus C over A, and I'm allowed to do this because remember, they said A, B, and C are non-zero. Similarly, you're going to get A plus C over B for Y, and Z will be A plus B over C. Okay. So I've got X, Y, and Z. Now, do I just want to jump straight into this expression? I can now turn it just in terms of A's, B's, and C's. I don't know how useful that'll be, but A plus B B plus C. I was reading them backwards there. B plus C over A plus C over B. And just the number of fractions I'm getting, I'm now thinking the answer might be something like 1. But again, we'll see. There might be a lot more work to do that I'm not seeing. But I think I'm going to immediately want to get a common denominator, and so I think there's going to be a common denominator of A, B, C for everything. So we get B plus C, A plus C, A plus B, all over A, B, C, minus BC, B plus C, plus AC, A plus C, plus AB, A plus B, all over ABC. So maybe when I combine these two fractions, they'll cancel out and just be leaving me with an ABC on top, in which case the answer would be 1. Because I don't think everything's going to cancel on the top to get a 0, but again, we'll see. Okay, so expanding out my product down for the first one, you're going to get a squared b, a b squared a, an a squared c, a c squared a. I can get these, right? So, yes. And then I can get a b squared c and a c squared b. And I think there's going to be some number of... All I'm doing is saying, well, you can do c, c, and an a, or c, c, and a b, or the two b's and a c, or the two b's and an a. So that's how I've got those ones. And then there's going to be some number of possible ways to get a, b. Oh, maybe I can't get a, b, and c. I should get 8 terms here. Okay, I can get a c, a, and a b. I can get an a, b, and a c here. I think that's it, and those are my other two products. So 2 A, B, C's. And so maybe the answer is 2. Maybe I was wrong. And then we subtract off so I'll get b squared c. Yeah, there we go. B squared c and c squared b, and then an a squared b and a b squared a. I don't think I have those in exactly the right order, but a squared c and a c squared a. And all of this is over a, b, c. Right? Yeah, we'll get 6 terms there. And now we play the cancellation game. Cancels, 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 cancels. And I'm left with 2. I really didn't think it would be anything other than... I was pretty positive it was going to be 0, just from the subtraction there, but look at that, it's 2. Now, with a question like this, if I wanted to, I could very quickly try and figure out, just say, well, let's let A be 1, B be 2, and C be 3, or something like that. Just pick A, B's, and C's, try and find X's, Y's, and Z's that satisfy these, and make sure that x, y, z minus x plus y plus z really is 2. Okay? You could definitely do an example to show that this is 2. That's not going to cut it with marks because they do want you to, figure out how to evaluate the whole expression. But I'm going to grab my calculator real quickly and just pluck out some A, B's, and C's. So, I don't know, let's let A be 1, B be 2. They didn't have to be positive or anything like that, right? It's just non-zero. So I'll let C be, I don't know, negative 1. Okay? So the sum of these is going to be 2. So I know that by plus b is equal to 2, so y is going to have to be 0. I know that ax plus a is 2, so x is going to have to be 1. And I know cz plus c has got to be 2, so bringing the minus 1 over to the other side, I get 3. Divide by minus 1, I get minus 3, so z is minus 3. So the product of these, x, y, z, is going to be 0. And the sum of them is going to be 1 plus 0 plus minus 3, negative 2. And 0 minus negative 2 really is 2. Okay, that's kind of nifty. It worked out. And I'm always happy when I'm pleasantly surprised when I think I'm going into a question. I'm like, yep, this is the technique, this is the answer, and they throw something slightly different at me. So I'm really happy with that question. And hopefully question 6 will make me just as happy, because remember, math contests are all about fun. Okay? Yeah, I know things like the Manitoba Math Competition and like the Euclid or the Fermat, they carry some big weight behind them, because if you do well on them, people will start to notice your name, recognize you, give you scholarships, invite you to camps and things like that. But above all, doing math like this is supposed to be fun, and that question, especially the B part, was really fun for me, so I liked that. So I will see you guys for question number 6 in the next video.